Welcome to Department of Collegiate and Technical Education, and also Department of Mechanical Engineering. My teaching subject is metal casting and welding. Module 2, chapter is melting and the metal mold casting methods. Session 1, myself is Muniraju K, Assistant Professor, Department of Mechanical Engineering, Government Engineering College, Ramanagara. So initially, I would like to tell about course objectives. So course objectives in this topic is to understand principle involved in metallic molding process. Metallic molding process. In model 1, so that sand molding process we are studied. So in the model 2, we're going to study the metallic molding process. Contains introduction, gravity die casting, pressure die casting, cold chamber pressure die casting, hot chamber pressure die casting. Contains today's topic. It contains, these are all the contents. Next, introduction to metallic molds. Sand molds serves as a single purpose molds, that is temporary and is completely destroyed after the casting has been removed from the mold. New mold has to be prepared for each new casting. Hence, to overcome these limitations of the sand molds, we're going to use metallic molds. Sand molds to be prepared each and every process because it's a temporary. Okay, metallic molds are permanent molds, so no need to prepare each and every castings. Once we prepare for metallic mold, you can use n number of times. Metallic molds are fabricated out of ductile materials. Usually, you're going to fabricate metallic molds using ductile materials. So initially, we're going to talk about gravity die casting or permanent mold casting. It is referred as gravity die casting or permanent mold casting. The process makes use of metallic mold to produce the castings. Two hollows of dies are used to produce the casting. The die hollows are cleaned well first. Then the dies are preheated. The dies are coated with refractory mold coatings. The die hollows are closed and clamped. Molten metal is then poured into the cavity via sprue or pouring cup and allowed to solidify under gravity or atmospheric pressure. Metal is then allowed to cool. After solidification, casting is removed by opening the mold or die hollows. The molten metal cools faster in the metallic molds than in sand molds. 6 mm thickness can be cast. So this is the diagram of gravity die casting. So two dies or two hollows, first one and second one, metal mold hollows. Okay, this is the riser or pouring cup. Okay, this is the cast or object to be cast. So post hinge for closing or holding two metal die castings. Okay, clamp is there. Okay, we're going to pour the molten metal here, pouring cup, and the riser will be there. The excess material will come and accumulate here. So this is the cavity or object, shape of the object we require. Okay, by closing two holes, you're going to pour the molten metal and allow it to cool for some time for solidification. This is the solidified casting. Okay, this is the extra screw we need to cut. Casting, gravity die casting. So it is similar to this one only. What the casting of sand casting. Here you're going to use, instead of sand, you're going to use metallic molds. Next one is pressure die casting. Here also a permanent mold in two hollows is used to produce the castings repeatedly. But external pressure is used to force the molten metal into mold cavity. Hence, much thinner castings can be produced as compared to gravity castings. It can be further classified as low pressure die casting, LPDC, low pressure die casting, and high pressure die casting, HPDC. Low pressure die casting, LPDC. Here, the pressure of approximately 1 Newton mm square is applied on the molten metal during the solidification. Die halves are closed and molten metal is poured into the mold cavity, and the pressure is applied immediately. After a few minutes, the die is opened and casting is removed. So this is the diagram of low pressure die casting. This is crucible is there. It contains molten metal liquid, and bottom die is there, top die is there, cavity is there, required object, compressed air is there. Compressed air used to move the molten metal into the, or forced to move the molten metal into the cavity. This is the casting. So refractory tube is there. Construction we'll see. Construction, it consists of crucible positioned inside the crucible. It consists of crucible. Crucible is this nothing but it contains molten metal positioned inside the resistance type electric furnace. It's an electric furnace. The function of furnace is to convert solid metal into molten metal. The metal ignores are placed inside the crucible and current is passed through the coil. Temperature of molten metal is maintained constant. So once the molten metal, solid metal is converted into molten metal, the temperature is maintained constant. The entire crucible and furnace is housed inside the metal chamber. The lid of crucible is closed with asbestos lined hollow plate with an opening for passing air through the plate. The plate has holes extended to the inside of crucible. A refractory tube enters the molten metal bath and connects to the die cavity. Whenever a compressed air is passed through the opening, the molten metal is pushed upward through the pipe into the die. After the metal cools, casting is removed from the die. Thin castings can be made. So related, this one is there, diagram is there, so crucible is there, compressed air will push the molten metal into the casting, cavity. Okay, once the molten metal occupies the cavity, you're going to allow for cool or solidification. You're going to remove out. This is the casting. Next, high pressure die casting, HPDC process. So we'll see the first we'll go for diagram. Diagram is there. See here, pressure is there, cylinder is there, ladle is there, cylinder piston is used to push the molten metal into the cavity here. Ejector pin is there. Once the cavity, sir, once the casting is formed, you're going to remove the casting through the ejector pin. So this is the diagram. Cold. Okay. A pressure of 7 to 500 Newton mm square is applied on the molten metal during the solidification. Very thin and intricate castings can be made. Very high mechanical properties, good surface finish castings can be produced. Section thickness 6 mm can be easily produced. Any metal or alloy can be cast. Very large number of castings can be produced in a single die. High pressure die castings can be classified into cold chamber die casting process. Hot chamber die casting process. In cold chamber die casting, molten metal is poured outside the die chamber and then forced into the die. There will be drop in the metal temperature by the time it reaches the die cavity. A separate melting unit is used to prepare the molten metal. See, high pressure die casting is divided into two types: cold chamber die casting process and hot chamber die casting process. In the cold chamber die casting process, the molten metal is poured from outside the die chamber, then forced into the die. There will be drop of metal temperature by the time it reaches the die cavity. In hot chamber die casting process, molten metal is carried through the unit which submerged in the molten metal itself. The metal or molten metal is forced into the die cavity, hence metal does not lose any temperature at all. So hot chamber, here the die is installed within the hot chamber. No external pouring of the molten metal to maintain the temperature. The molten metal in the die, when it reaches the die, it's not going to lose the temperature. First, we will take up cold chamber die casting process. So it consists of the cylinder and plunger arrangement. One end of cylinder is connected to the movable die. A fixed die engages the movable die. A movable die and cylinder move together. The cylinder has opening on the periphery. Through this opening, molten metal is poured inside the cylinder. As and when plunger moves towards the die, molten metal forced into the die with high pressure. The dies are separated after a few seconds by help of ejector. Solidified casting is removed. The process is repeated. Dies in closed position, molten metal poured into the cylinder. The construction. So this is the principle and construction I'm talking about now. The dies are closed. The molten metal is poured into the cylinder. The plunger pushes the metal into the plunger is there here. Plunger pushes the metal into the die. Movable die and plunger moves out. Ejector pinch pushes the casting out of the die. Die close and ready for the next casting. Very high pressure of 20 to 200 Newton mm square is applied through the plunger. As I explained, so externally we are going to pour the molten metal here through the ladle. So it's a pouring from molten chamber to here. The ladle carries the molten metal. But we're going to pour the molten metal here, and the plunger pushes with high pressure. It pushes to the cavity and allowed for pulling the ejector pin. By using the ejector pin, we're going to take out the castings. So this is the cold chamber die casting process. Next one is hot chamber die casting process. As I said earlier, see, gooseneck is there. This is the pipe which carries the molten metal into the die or cavity, is submerged in the pool of molten metal or chamber of molten metal. Okay, to maintain the required temperature. No external pouring. Okay, so using compressed air. First one is hot chamber die casting process using compressed air. It consists of a gooseneck chamber housed in the melting pot. So this is the gooseneck housed in the or submerged in the melting pot. Melting pot holds the liquid metal and heated by the furnace. The furnace is there which holds the liquid metal. The gooseneck has nozzle at one end. So nozzle is there which connects to the die opening. Die is there. Nozzle which connects to the die opening. The die is closed and gooseneck chamber draws the molten metal from the melting pool or melting pot. Now compressed air is allowed into the gooseneck chamber. This force the molten metal into the die cavity. The molten metal solidifies after a few seconds. The die opened and solidified casting is ejected out. The die is ready for next cycle. This is the hot chamber die casting process. Die is there, ejector pin is there. So we're going to take out the casting from the cavity. Next, hot chamber die casting process by using plunger. Earlier we have used compressed air. Now we're going to use plunger to push the molten metal into the die. It consists of a melting pot. Again, it is consists of a melting pool with gooseneck. Here also it contains gooseneck secured into the brick lining. The pot is heated from the outside. A burner is located which supplies the flame or heating the pot. Molten metal enters the gooseneck. Molten metal enters the gooseneck chamber through the inlet. Through the inlet. The gooseneck portion of the chamber ends as nozzle and connects the opening of dies. The die is closed to start with. The gooseneck chamber draws the molten metal from the pot and gooseneck connects the die. Now the plunger moves down, force the molten metal into the die cavity. Plunger is withdrawn after few seconds. After few seconds, metal solidifies. The die is opened and casting is taken out. The die is ready for next castings. The burner keeps the metal at the constant temperature always in the pot. The hot chamber means it should not lose the temperature. Molten metal should not lose the molten temperature. So this is the first session is completed. We'll meet in the next session, session 2, that is session